Hey guys, today I want to introduce my new project, live following robot using the PID algorithm. Building a high-speed live following robot has been my dream ever since I started watching them on YouTube. They are incredibly fast, they look cool, and building one requires a lot of real engineering knowledge. So today I'm going to show you how I build mine. And first, let me show you the structure of the robot and explain what each component used for. First is the power supply. I use two battery 18650. This provides high current needed to run the motor at top speed. And the second is motor driver. It takes the signal from the brain and puts the actual power to the motor to make them spin. And the next is microcontroller. This is the brain. I chose the LGT8 over a standard Arduino because it has a faster clock speed, which is crucial for calculating the PID math quickly. And next is the converter here. Bus converter is used for adjust the voltage to the value unit, and a button used to trigger the different mode of the robot. A LED, a symbol visual indicator to show what state of the robot is in, and a voltmeter. It will show the voltage of the battery so I can know when the battery is run out. A pulser, providing audio feedback when the robot calibrate or start. And analog light sensor here. Analog light sensor. The eyes of the robot is an 8-channel sensor that reads the reflection of the track to find the black line. And this is the part of the robot at the bottom. Okay, so second, let's talk about the brain of the robot, the PID algorithm. And what PID means? Comprised of two components, P, I, and D. P stands for proportional. This is the muscle. It looks at the current error. If the line is too fast to the left, P still hard to the left, but P along each circuit. So we use the next values ED. This means derivative. This is the break or the prediction. It means when the robot is too far from the line, P value will have the robot rotate to the line, but if it rotates too fast, it will miss the line again. So the D value is used for this condition. It will control the robot to slow down when it reaches the center of the line. And the final is the interval, means I. This is the memory. It looks at the past errors for high-speed live follower. We actually set it to 0 because the robot moved too fast to care about the past. So, but what happens if we turn this value incorrectly? If B is too low, the robot becomes lazy. It won't turn fast enough and will simply ride off the track at the first safe corner. If B is too high, it becomes overly aggressive, randomly checking left and right like a snake. If D is too low, the robot will wobble. It will constantly overshoot the sensor line because it doesn't know how to brake. On the other hand, if D is too high, the system becomes stiff. The motor will shift and if raised, the robot will actually reach too slow to real course. Finding the perfect mathematical balance between P and D is the hardest first mod reversing part of this project. And first, I will ram the robot with 3 distinct modes to make it completely autonomous. And first is calibrate. And why we do this? Because the analog signal from the sensor change depending on the room lighting and the track material. The robot takes 5 seconds to sweep the track and learn exactly what black and white look like in this specific environment. Here, the next mode is active alignment. This is a whole mode. Before the race, the robot uses PID algorithm at 0 speed to actively clock its sensor perfectly to the sensor and receive being first. It's a great way to test the PID stiffness here. It looks cool. And the final mode is actively racing mode. The base bit kick in and the PID algorithm take over to keep the robot on the track at high speed. For the code structure, let's briefly look at the code structure. I keep the architecture clean and orderly, dividing it into 3 main blocks. First is the setup block. It is where we initialize the hardware pins, run the 5-second auto calibration while loop, and enter the active alignment mode. Second is main loop. It incredibly short. It constantly reads the sensor array, calculates the error with the compute PID function, and send the function speeds directly to the wheels. First is the hyper function. It consists of writing messy code and separate the code logic into specific function. Get line position, handles the way arrangement to find the center of the line, and control motor handles the H-brick logic for both forward and reverse bin. So finally, let's see all the bit hardware and math come together. Here we have the robot handles a complex math with acute angle and short turn. So yes, this is the end of the video. Hope you like it, and bye.